Welcome back, my dear friends. A very good morning, good afternoon and good evening to all of you wherever you are in this part of the world. And as you know, this is the DADM2, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. And we are in the last class for the 11th week, and this total course duration, as you know, which I tell before I start of the lecture, is for 12 weeks, which is actually of 30 contact hours, which gets converted into 60 lectures, because each lecture is for half an hour, and each week we have 5 lectures, and after each week we have assignments. So, with this end of this lecture you will have the 11th week assignment, and then next week you have the 12th week, the last course for the wrapping up. So, if you and my good name is Raghunandan Sengupta from the IME department at the IIT Kanpur. So, if you remember, we were discussing about the concept of artificial immune system, the concept of positive selection, negative selection, and how the general concept of antibodies, antigens and pathogens basically are the building block, the ideas are the building block based on which the artificial immune system can be built up. And we will further discuss that with an example either today or in the next class, which will be in the first lecture of the 12th week. So, for the general framework for the AIS, which is the artificial immune system, is a representation for the components of the system is very essential, which means a set of mechanism is to be evaluated such that the interaction of the individuals with the environment and each other can be made. So, if you remember, they can be primary and secondary reactions or the fighting mechanism. In the primary one, pathogens come and the antigens or the good cells combine them, and in the secondary one, depending on some prior information set, these cells are ready to fight the invading virus or the bacteria. The environment is usually simulated by a set of input stimuli. Stimuli can be either high temperature, low temperature, cough and cold, so on and so forth, based on which the stimulus occurs for the replication of the cells. In a set of input stimuli, one or more fitness functions could be utilized in place of the stimuli in the actual utilization, or other means can be also utilized. A procedure for the adaptation that govern the dynamics of the system, that is how its behavior will vary or evolve with time, would also be briefly discussed and analyzed. Now, whenever you are trying to basically find out the best state function and how the replication can be done, or how good or bad the solutions are with respect to what you want to achieve, whether maximize, minimize, or want to basically have some combination of them, we will basically have different concepts of distance functions. So, distance functions can be quadratic, can be L1 norm, can be L3 norm, can be infinity norm, can be Bhattacharya distance, can be in from the point of view of statistics, can be Hamming distance. So, all these things can be compared. We, for our problem in this case, when we are trying to solve the problem, we will consider the Hamming distance for our discussion. So, representation would be done by a vector of size of, say, for example, L would be all the individual components based on which the characteristics of the representation of the similarity dissimilarity can be done. So, it will describe the interaction between the molecules. Molecules means the like, say, for example, there are attacks happening from 3 different types of viruses, and we will consider each virus has some characteristics based on which the fighting WBCs would be built up. So, and consider the distance function or fitness function based on which we will try to build up the model is 4 in number. So, the first virus would have 4 such matching to be done, similarly for the second one and the third one. So, it describes the interaction between the molecules, and the degree of binding or the affinity between the molecules will also be based on this fitness function. For the fitness function, if you remember, I had considered the concept of distance measures, and I did mention what are the distance measures like the L1 norm, L2 norm, L3 norm, L infinity norm, and all these things. And we will basically have a threshold based on which we will try to find out how close or far the fitness function is. It need not be the fitness function fit is the best, they may be error like epsilon errors, but what is the value of epsilon based on which we will take a decision, yes, this is a good fitness function and we should proceed, or no, it is not a good fitness function, based on the tolerance limit we should not proceed. We should basically be able to say that beforehand before we analyze the problem, and based on that we build our methodology of AIS. So, generally the basic immune models and the algorithms are based on the negative selection algorithm, positive selection algorithm. What are these? If you remember in the last class, in the 54th class, I did mention that in the positive and the negative we start with the bad set and build up on that, and in the negative selection we start with the bad set and build up on that, and in the positive selection we start with the good set and build up on that. Clonal selection would also be considered, where the replication of the cells or replication of the so called algorithms or the optimization problem would be built up on a set of say for example, a seed. Seed means when you start off a random number generation, or say for example, you want to generate some numbers, you basically start with a seed or a value based on which you will build up those values. So, based on a seed you will basically try to replicate how good or bad cells can be built up such that your fighting mechanism can be built up. In this case, the fighting mechanism is basically how close or far it is from the fitness function. And the immune network models would also be built up based on this negative selection, positive selection and clonal selection algorithms. Now, this negative selection problem we will take the general formula idea from Forest's paper in 1994. So, the process I will just give you the general process how it works. So, the process basically works on the idea that you will basically have a matching set. I will describe the matching set later on, but so you will basically have a matching set. So, what is the matching set? I am going to come to that later, and some generated candidates are coming. That means, generated candidates means I have a cell which wants to fight, and then the attack is happening from the external sources. So, this we will consider as the generated candidates who come. I match, I find out if the matching is good. In that case, viruses are coming, my antibodies are there, my antigens are there, antigens fight, they find the matching is good, they club together, deactivate each other and they become dead. That is process, that is what was the general idea. So, in this case, once the generated candidates comes, and what you do is basically you consider a self means the type of WBCs which is going to fight. So, in this case what you will do is that you will basically have a so called generated initial solution. So, that would basically be the self, and the candidates who are coming are basically the different type of feasible regions of the solution space which you will consider that whether they are good or bad. So, you will basically consider a self type of solution which you think is good. That is good or not, that is a different question. You think that is good based on the prior set of informations, and you basically try to compare that solution which you had with the generated solution which are coming from the feasible set. If they match, you throw them away. If they do not match, you basically put them in a separate set which is basically denoted by S. So, initially S is an empty set, null set, and you try to basically keep those elements in this set. So, what is happening is, in general, negative solution means that I will throw away the so called good ones and keep the bad ones. So, in the process as I do, the solution which are thrown away obviously would be the set of solutions amongst which I will get the best solution. So, this basically I am trying to go in a negative direction. Negative direction means I am trying to do away with the solutions and basically choose one among those. So, once this set has been developed, the detector set has been developed, we will basically match those detector set with the existing solutions, and so detector sets are the negative ones, remember that. So, you will basically match the competence level or the closeness level of the rejected ones, and obviously it will be as far as possible. Based on that, we will try to replicate and get how such solutions can be detected and made more in numbers, as that the solutions which are being rejected in the negative selection algorithms would slowly build up, such that we are able to use the best amongst the negative set of solutions which is the so called best optimum solutions. Now, in the positive selection procedure, the method just happens in the other way. So, how it is does it done? So, we basically take a matching set. Again the sets of solution generated candidates which are coming are mapped, but now if they match we put them in that S set. Initially we were putting only the bad elements in the S set, now we will put the good elements in the S set and throw away the bad ones. And based on the detector set which has been basically, which was S, which builds up with the good values, we now basically replicate the problem in exactly the same way as we have done in the previous case for the negative selection algorithm. So, in the negative selection algorithm, we keep in the detector set the bad solutions, and in the positive selection algorithm we keep in the set S the good solutions, and based on that we replicate and try to find out the solutions. I will come to the example in few minutes. Now, in the clonal selection algorithm the process will build up. So, how does the process build up? So, this is, if you remember, the clones would be built up or they would be generated in such a way that in the initial problem, in the actual medical concept, we said that they should be built up such that they are able to fight the pathogens which will be coming to attack the system or attack the body. So, we will try to basically replicate the same concept in order to build a solution set in a much better way. So, the initial populations of the memory set or the set based on which we will try to replicate would be considered, and we will basically clone them. That means, we will have a infinite sets of such near optimum, not near optimum solutions, near feasible solutions, all feasible, but they are basically competitors to each other. They would be built up and added to the population. So, once you select a memory cell and place in the memory pool. So, say for example, you increase the population. Increasing the population means that you are trying to replicate it as close as possible to the probability distribution function of the population or the probability mass function of the population, and based on that you will basically you replace, as you are replacing them, you are replacing the less affinity ones, that means the ones which have the least matching. So, as you do that, you basically build up a population which have the almost the same characteristic based on which you can replicate and find out the best solution in the best possible manner. That means, you are slowly building up your population, doing away with the ones which are further away from your actual population, and basically build up a solution which are near optimal, and based on that you can build up your model. Now, we will basically try to consider in our case a problem in the area of finance. So, to give a brief background, so we will use the concept of negative selection algorithm, positive selection algorithm, clonal algorithm, use the concept of antigens, antibodies, pathogens, and how they can be utilized in trying to basically build up a very simple directing model in the area of finance. So, in generally bankruptcy prediction models, we have different type of models which have been developed starting in the 1960s. The main person who or the frontier person in the area of building up such models was by the name of Altman. So, Altman basically proposed the Z score in the 1960s, and there were other scores also developed by Altman and his set of researchers. One was the Zeta model, which is now used as a trademark by many of the banks. Then you have the Olson score, which is the O score. Then you have again another Altman's model, which is the emerging market model, where the models were more specific to the emerging market as the economy developed. You have the Zurbriggen model, Zimzewski models, and all these things are part and parcel of the bankruptcy predictions model. And they are all mathematical in nature, and starting from 1960s to 1980s and 1990s, the models were developed in a big way. So, these are all statistical methods in general. Now, we want to basically utilize the concept of AIS to build up a prediction model of bankruptcy and compare our model with respect to any of the existing models like the Altman or the Zeta model or the Olson scores or the emerging market scores and all these things, and see how good or bad our models are with respect to the general sample we are going to take to predict this bankruptcy. Now, here what is the main idea for our problem is to basically, the problem is basically to distinguish between the self and the null self. That means, the good and the bad companies or the bad or the good companies depending on how you have been able to define the concept of negative selection and positive selection. So, the problem would be to basically detect the SIC companies from the non-SIC companies, or the non-SIC companies from the SIC companies, depending on how you, as I just mentioned few seconds back, you are which model you are going to use in order to build up the detection algorithm. So, the metaphor for our example would be SIC companies can be considered as the antigens, and the non-SIC can be considered the cells which will basically replicate themselves in order to basically give a much better prediction how the good companies are doing based on many of the parameters. So, obviously, the question will come that what are the parameters we will consider to build up our model. So, in the bankruptcy prediction methodology, the concept would go like this: you select a sample of companies consisting of both SIC and non-SIC companies. So, it will basically be both. Now, there should be a choice of explanatory variables or the set of indicators which will be utilized to represent how good the bad the company is with respect to is whether it is going to fail or not fail. So, the parameters can be the assets, can be the market share, can be the balance sheet variables, can be the depreciation value, can be the amount of loan the company has taken, can be the stock market, can be the land prices, can be the ratio of the sales to total assets, there can be different things. So, in general in accounting we have about 14 ratios based on which we can analyze how the company is doing good or bad. Apart from that, as I mentioned, the market share concept, the concept of stock prices, all this can be utilized to predict how good or bad the company is doing in the coming days and how it will do in the future. Now, there should be a choice of, as I said, there should be a choice of explanatory variables, sets of indicators to represent the firm's optimization model with constraints which differentiate the companies which are good from the bad, and these variables should be such that they would be able to give us a much better idea. So, what we will do is that we will basically make a binary classification system. So, that would be there would be two classes. So, one of the classes would be SIC, another classes would be non-SIC companies. Point 1. Point number 2 is that, say for example, all these 14-15 ratios we consider, we will basically have a distance measure and try to find out how good or bad these distance measures are when you basically compare one of those parameters or any one of the characteristics based on which we can analyze whether the company is doing good or bad. So, I am not saying that there would be only one characteristics, there would be 14 to 15 different ratios. We will try to compare these ratios individually and then try to basically find out the best combination which will give the set of class which are good and the set of class which are not good. That means SIC and not SIC. We will generate a set of detectors using the AIS concept of selection, as I mentioned. So, those mapping would be done for the ratios onto the AIS measuring scheme or the distance scheme. We will monitor the test data and use the detectors to monitor or classify the companies into the companies into a test data set, depending on the fact whether we are going to take the negative selection algorithm or the positive selection algorithm. In the negative selection algorithm, the process will work like this. So, we will define the set S which constitutes the group of non-SIC companies, that means who are good. Based upon the negative selection algorithm, generate a set of detectors A. So, detectors means what are the variables based on which we will study. So, these will be responsible to identify all the elements that do not belong to the self set or the non-self elements which are there. You will generate random elements M of the string of length L using the representation adopted. You will compare and match the candidates element M with the elements in S, compare them how good or bad they are. If the distance of the candidates elements M with at least one element in S is greater than the crossover or the threshold value R1. So, it can be R1, R2, R3, R4 depending on how you have been able to represent that. Then a mismatch would be said to have occurred, and this element M is stored in the detector set A, otherwise it will be rejected. So, this is the negative one. In the other case, positive one, it will just be the opposite. You will repeat step 2 to 3 until the required number n of detectors have been generated, and after generation of the set of detectors A, the next set of algorithms would be consisting of monitoring the system for the presence of non-self patterns, as that how good or bad the repetition would be in the future. So, this is the actual negative selection algorithm which will be utilized. So, the input set would be the set of S consists of reactivity threshold or the number of detectors required, which would be of length L, and the length of the string based on which we will do the comparison L in number. So, these are all numeric values. So, the output what you want to do is that basically have a non-empty set A, which would basically consist of the detector set. So, generally we will take the number of detectors starting from 0. So, you put j is 0 and continue to doing that for each and every comparison till j is n. Now, we will consider that m as the random variables and we will basically compare the distance function between m and s. So, m is basically the set where we will try to basically put these detectors and non-detectors depending on the negative the positive selection, and s would be the comparison set. And if that, and you obviously have a distance function. So, if m and s elements have a distance function greater than less than, you will basically put those values from the m into the s set or outside the s set depending on whether the matching is less than equal to some epsilon value for the distance or greater than that. So, you continue that, then you will basically increase the j to j is equal to 0 to 1, again compare for all, follow all the steps and continue doing that till you exhaust all the values of j. Now, we will basically find out the modified negative selection followed by the positive selection model. So, what you are trying to do is basically you are trying to replicate that, first you do the negative one, then you do the positive one. Now, there is a reason for that. Reason being that I'll just talk about here before I proceed. Say for example, I am trying to detect a company which is good. So, I do not know the actual whether the company is good or bad, but I think based on the variables I want to basically pass some judgment. Now, it may be possible that that company, even though it being good, it can be clubbed as a bad set. That means, there is an error. On the other hand, a company is bad, and I know that and technically should be bad such that there is no error, but it may be possible that the bad company is clubbed as good. So, in this both the cases we have a type of errors which are known as alpha and beta, and which is basically I am taking from a statistical point of view. The general concepts it would be that trying to basically minimize both alpha and beta separately is not possible. So, what we will try to do is basically try to analyze the error such that the sum of the errors of alpha plus beta would be minimum. So, when you are trying to do that, you will basically have the type 1 and type 2 error under the concept of H naught and H A, which we have already done in DADM 1. So, once that value of alpha and beta is given, we will try to minimize that. So, generally the concept is done in such a way that the minimization is done keeping beta fixed, we basically try to minimize the values of alpha as far as possible. So, this is the general concept which we will try to basically follow for our case. Now, in the positive selection algorithm, what as the thing which we have done for the negative selection is basically do the negative way or the distance function being matched such that we put away which are not matching in the other set, but in the positive set we will try to basically follow that, we will club those which follow as close as possible we will put in that set and required, and then basically try to match them as close as possible. So, in the general formulation which we are going to do is that we will first run the negative selection algorithm, then the positive selection algorithm, and in the other way we will basically run the positive selection algorithm, then run the negative selection algorithm. So, with this I will close this 11th week class and start discussing about the problem in the first class of the last week, and hopefully with the end of AIS which would happen in the 56th class, we will be able to cover another 1 or 1.5 topics in the area of meta heuristic techniques. Have a nice day and thank you very much.